Now we are going to see the distance interpretation of modulus. Modulus can also be interpreted as a distance magnitude. Okay, you can think of modulus as distance between something. So let's see how it actually works. So if x is a coordinate of a point on real number line, then distance of x from the origin is represented as modulus of x. Let's say I want to find out distance of 6 from origin. I want to take distance of 6 from 0. Now I can take it as modulus of 6, which is equal to 6. So that gives me distance of 6 from 0 is 6 units. Now what if I'm trying to take distance of minus 4 from 0? That will be modulus of minus 4. That gives me 4. So that tells distance of minus 4 from 0 is 4 units. Okay, so modulus can also be thought of as distance of what you have inside from the origin. So the distance of x from the origin is represented by modulus of x. We are going to delve deeper into the distance approach as we solve problems. I'm just introducing the distance approach of modulus. So in this case, if I want to completely interpret all these three in terms of the distance approach, so let's see how we can think about it. So modulus of x is 3. Oh, well, that means x is something which is 3 units from the origin, right? That's what I can understand. X is something which is 3 units from the origin. So from the origin, if I go 3 units, probably I can go on the left side and reach minus 3. If I go on the right side, then I will reach plus 3, right? So that tells me that the value of x could be minus 3 or plus 3. Okay, from the origin, you go 3 units wherever. If you want to go to the left, you can go to left. You want to go to right, you can go to right. You will find there are 2 points which are 3 units from the origin. So in this case, we can conclude that x can be minus 3 or plus 3. Okay, now let's look at the next one. Modulus of x is less than 3, which means there is something which is less than 3 units from the origin. So where can that something lie? It could lie anywhere here on the left side of 0. It could also lie anywhere here on the right side of 0, right? So once you know that there is something which is at a distance which is less than 3 units from the origin, it can lie anywhere in this place. Okay, so we can say that x can lie between minus 3 and 3. So x is going to be greater than minus 3, less than 3. Okay, so that the distance of x from the origin never crosses 3, it is always less than 3. Now, modulus of x greater than 3. When you say modulus of x is greater than 3, then x is something which is more than 3 units from the origin, right? In that case, x has to lie here or x has to lie here, right? So I can again put my minus 3 and plus 3, but this time x is going to lie this side, and for plus 3 x is going to lie outside. So x is going to lie to the left of minus 3 or to the right of plus 3. So this is a pure distance interpretation of modulus. Okay, that's cool. So modulus of x is distance of x from origin. Now what if I want to find out the distance of something from a point other than the origin? Okay, let's say I take a number line. From 0, if I try to find distance of 6, modulus of 6, the same example that we used earlier, okay, then I would measure the distance like this from 0, whatever is the distance of 6. Now, if I want to measure the distance of 6 from 2, not from 0, so that might be lying somewhere here. So what I should do is I should subtract this distance, right? So what happens is whenever you want to find out distance of 6 from a point other than 0, then you might have to do something like this: modulus of 6 minus 2, because I am trying to find out the distance of 6 from 2. So distance from 0, you subtract distance from 2. So modulus of 6 minus 2, if you do, you will be able to get distance of 6 from 2. That will give you the answer as 4. Okay, so this is also, earlier we were actually doing this. So this one is effectively modulus of 6 minus 0. So we are finding the distance from 0. If you want to find from 2, then you do modulus of 6 minus 2. That will tell you the distance of 6 from 2. Okay, now let's see how we can mathematically represent it in general. So what if you have to measure a distance from a point other than 0? Distance of a coordinate x from A is given by mod of x minus A. So whenever you see mod of x minus A, you can think of it as distance of x from the point A. If there is nothing given here, then you can take it as distance of x from 0. If mod of x minus A represents distance of x from A, then what would mod of x plus A represent? Distance of x from minus A, right? That will represent distance of x from minus A. So that's how we can find out distance of something from a point other than 0. So this is distance of x from minus A. Okay, now let's look at this. Modulus of x minus 1 is equal to 3. So we know that when I have modulus of x minus 1, that means distance of x from 1, right? So x is something whose distance from 1 is equal to 3. Now we'll have to choose our x in such a way so that distance from 1 is equal to 3. So let's see where our x could lie. So 1 is where I am finding the distance from. From here 3 units. So I can go 3 units to my right. That will put me at 4. If I go 3 units to my left, that will put me at minus 2, right? So here I can say x can be equal to 4 or minus 2. Now let's look at the next one. Modulus of x minus 1 is less than 3, which means distance of x from 1 is less than 3. So we know that if the distance is 3, I can go till minus 2 on my left and till 4 on my right. So if it has to be less than 3, then I have to stay within this area, right? So I can say x has to lie between minus 2 and 4. It can be greater than minus 2. It can be less than 4. It has to lie between this range. Now if we come for the next one, where we see distance of x from 1 should be greater than 3. If it has to be greater than 3, then it has to lie outside this. So I can say minus 2 and 4 I can put, but this time x has to be less than this. So x should be less than minus 2 or x should be greater than 4. Does anyone want me to repeat this? Okay, I'm going to quickly repeat, guys. Please listen. So what we're doing here is we have modulus of x minus 1 is equal to 3. So the first thing to understand here and to be clear of is what is this modulus of x minus 1? So what does this actually mean? From the distance interpretation, this means distance of x from 1. That's a distance interpretation of modulus. So modulus of x minus 1 means distance of x from 1. So if we say the distance of x from 1 is 3, so from 1, x is 3 units away, right? So I can go 3 units to my left. If I do that, I will land at minus 2. If I go 3 units to my right, I will land at 4. So on the basis of that, I can say x has to be either 4 or minus 2. When I look at the next one, which again means distance of x from 1 is less than 3. We know that these are the boundary points for distance being 3. So if it has to be less than 3, then it has to be within the boundary points, right? So on the basis of this, I can say x should be within minus 2 and 4. And when I come for the next one, this says distance of x from 1 is greater than 3. Again, we know the boundary points are here. Greater than 3 means it should be outside my boundary points, right? So it has to be either less than 2 or it has to be greater than 4. So that's what I have written here. Properties of equations and inequalities involving x. So we are just going to quickly summarize here without having to draw the number line every time and figure out. Okay, so let me summarize here. So whenever you have modulus of x is equal to p, so in this case we can say either x is equal to p or x is equal to minus p. We have already seen this. And whenever you see that modulus of x is less than p means it's going to be the in-between range, not the outer ranges, in-between range. So what you can do is you can write minus p here and p here, and you can put x in between that. Okay, when I say modulus of x is greater than p, we are speaking about the outer ranges beyond the boundaries. So I can put minus p and p. But now I'll have to place x outside this. So x should be less than this or x should be greater than this. So without having to draw the line every time, we should be able to arrive at these three every time you see modulus of x equal to something or less than something or greater than something, which can also be represented using this, which is basically the summary of whatever we discussed. Now for this case, which is also very similar to what we already discussed. So in this case, it is equal to P. So I can say AX plus B is either P or AX plus B is equal to minus P. And in the next case, it is a less than inequality. So it's going to be the in-between range. So I can put minus P here, and in between I can put AX plus B. Now coming to the third one, it is greater than P, which means the outer ranges, the ones on the left and the right outside the boundaries. So I can say minus P and P, but this time I should put my values outside. So I can say AX plus B less than this or greater than this.